Howdy folks, welcome back. So in this video, I'm just going to quick go through the practice quiz and again show you how I would go about solving the problem. Again, I recognize it's by no means the only way. In some cases, it might not be the way that makes the most sense to you. If you have a way that makes more sense to you, again, as long as you end up with the correct answer at the end, you don't necessarily have to do it the exact same way that I do it here. But if you're curious as to where to start, this just kind of shows you how I go about going about the problem there. All right. So again, the quiz is going to be 3 questions, just like all the previous quizzes. So the first question in this case is asking for the quotient of 2 complex numbers. So we're trying to figure out how to divide these 2 complex numbers here. All right. So to find the quotient, what you're going to do is you're just going to multiply the top and bottom of your fraction by the conjugate of your denominator. All right. So the conjugate are going to be what you have when you have the same numbers. So we have 5 and 3i. And to find the complex conjugate, you're just going to take the same numbers and you're just going to change the sign. All right, so if you have 5 minus 3i, the conjugate of that is going to be 5 plus 3i. All right, and in order to say that the next 2 expressions are going to be equal, we have to multiply the top and bottom by the same thing. So if you multiply the bottom by 5 plus 3i, you have to multiply the top by that same number. All right, so that's just a matter of performing the multiplication with complex numbers. So again, we can FOIL this out. So again, that gives you the numbers that you need to multiply together when you have 2 binomials. So the F stands for the first number, so you're going to take the first term of each binomial, multiply those together. So we have 3 times 5, so that's going to get us 15. Then you multiply the 2 outside terms, that's the O in the FOIL method. So you have 3 times 3i, which is going to be plus 9i. All right, then we have the 2 inside terms are going to be multiplied together. So you have 2i times 5, so that's going to be plus 10i. And then finally, we have the 2 last terms of each binomial. So we have 2i times 3i, so that's going to be plus 6, and then I squared. All right. And then for the bottom, we can follow the same process. So again, we multiply the 2 first terms. We have 5 times 5, so that's going to be 25. We have the 2 outside terms. We have 5 times 3i, so that's going to be plus 15i. And then we have negative 3i times 5 is going to be minus 15i. And then negative 3i times 3i is going to be minus 9i squared. All right. So I squared, again, I is the square root of negative 1. So again, when we take a square root and we square that, the squared and the square root kind of cancel themselves out. So I squared is just going to be negative 1. So wherever you see an I squared here, we can put a negative 1. All right. So yeah, so then we take, in this case, 6 times negative 1. So this is going to end up being minus 6. All right, and this is going to be negative 9 times negative 1, so this is going to end up being plus 9. All right. So then we can combine like terms in the top and the bottom here. All right. So we have 15 minus 6, so that's going to be 9. 9i plus 10i is going to be plus 19i. All right, and then here the plus 15i and the minus 15i are going to cancel out. So we're left with 25 plus 9, which is going to be 34, I believe. Yep. Right. At this point, if you had a common factor in every single one of your terms, you can cancel out that common factor. In this case, you don't have a common factor in between that goes into every single one of my terms here. So this is going to be my final answer. All right, so the next question here is dealing with solving a linear inequality. All right, so to solve a linear inequality, you kind of follow the same process as when solving a linear equation. So again, our first step is we want to get everything that includes the variable that we want to solve for on one side, everything else over on the other side. All right, so we have negative 2x plus 7 is greater than or equal to 15. All right, so to get it, so I just have the x's on the left and my constant terms over on the right. I'm just going to subtract a 7 from each side. And again, just like with an equation, as long as I add or subtract the same thing on both sides of the inequality symbol, I haven't really changed my inequality at all. All right, so that's going to give me negative 2x is greater than or equal to 15 minus 7, which is going to be 8. All right, and then if we just want a single x here, just like when solving a linear equation, we divide both sides by negative 2. All right, now the difference between solving an inequality and solving an equation comes at this point. If you multiply or divide by a negative number, you have to remember to flip the inequality symbol. All right, so what we're going to be left with is x, and then we're going to flip this inequality symbol. So instead of being greater than or equal to, it's going to be less than or equal to. And 8 divided by negative 2 is going to be negative 4. And I'm fine if you leave it like that. That's perfectly a valid way of writing the answer. So this is what's known as set builder notation there. The other way is interval notation, which again, most of the time the homework prefers that way. So if you prefer to use interval notation, if that's what you're used to, the interval notation for this one would be from negative infinity up to negative 4. And since we have a line underneath that, we're going to use a brackets there. But again, I'm fine if you just leave it in set builder notation there. All right. So the final question here is dealing with functions. So it's just asking us to determine whether a relation defines a function or not, then state the domain and range of the relation. All right, so again, if you have a set of points, in order for it to determine a function, every single values for the first component have to be unique. So you can't have any repeated values in the first component and have it be a function. So for example, here we have the point 1, 3 and 1, negative 3. So since we have a repeated value in my first component, that means that this is not going to be a function. So not a function. If every single one of your values in your first component was unique, so for example, if this was a 2, 3, oh, that wouldn't work either. We'll say 3, 3. So yeah, so if we had, this was a 3, 3 or a negative 1, 3, I guess would have probably been the easier one to go with. Either of those, it would be a function because again, every single value in the first component would have been unique at that point. But in this case, since we have repeated values, a repeated value of 1, it's not a function. All right, so the domain and range. So the domain are going to be all the values for your first component, or all the x values there. All right, so it's just going to be a list of the values for your first component. So you have 2, 1, and negative 2. And the range are going to be all the values of your second component, or all the y values there. So we have 5, 3, 4, and negative 3. Yeah, that's all there is to it. So yeah, so hopefully not overly overwhelming there. But yeah, if you were curious as to how to go about solving problems, again, that's how I go about doing it. Again, I recognize by no means the only way, and in some cases it might not be the way that works best for you. But that's how I would go about solving the different problems. So hopefully you found this helpful. Have a lovely day. I'll talk to you all later. Bye now.